Hey guys, welcome to Videos on Archive tutorial. Thanks for watching our videos online. Please do help us subscribe. Please do press subscribe button and notification bell and also our updates on this YouTube channel. Thank you and God bless you. Amen. Today we will be considering what tips for physics examination, theory and objective. You are going to enjoy this class today, and I'm going to promise you, I'm going to give you the details of how your theory and objective on physics is going to look like. What are the major topics that you need to concentrate within this 24 hours of preparation? So we are considering what physics exam, theory and objective in what preparation in 24 hours. We have what Waec 2023 physics theory awards and objective theory and objective preparation in 24 hours. Preparation in 24 hours. In 24 hours to the exam. Now, we have what the Waec 2023 physics theory and objective preparation in 24 hours to the exam. Now, what are the things that you need to know within these 24 hours to your exam, or 48 hours to your exam? The first thing you need to know is that you need to know those topics that are usually come out, and you how to tackle them when they come out as you do your exam. Number one, we have what equation of motion. The equation of motion is very, very important under mechanism. Equation of motion. Then we know under this equation of motion we can classify it into what motion under gravity. Normal equation of motion under what gravity. So equation of motion, we have what we have the normal equation of motion that we use for our linear motion, which is kinematics. So the study of motion, kinematics, and this one also we can also group it under what motions under gravity. Motion under what gravity. These are the two major core topics. Motion under what gravity. Motion under gravity. That is motion under acceleration due to what gravity. Then you can also talk about what from there. We can also talk about what Newton's laws of motion. Newton's laws of motion. How do you apply it in what? In questions, Newton's law of motion. Also, what else again can we talk about under what motion? I think that's the major one. Kinematics, the motion under gravity, the Newton's laws of what? Of motion. So, although we have what? Gravitational universal gravitational field and what? And electrostatic field, but that is under what? Under different type of field. So now this is what equation of motion. Then we move to what? We move to projectile. These are the questions that they usually what? Ask projectile in the first section. So these are the questions in first section. Because in physics we are going to be talking about what? We are going to be doing in theory physics. We are going to have two sections, section A and section B. So in section A, we usually have all these questions in section A, including what? Including the gravitational and what? Electrostatic what? Field. So we have also projectile. Another projectile, what are the questions they usually ask? They usually ask questions that involve maximum height, range, time of light, we have maximum height, range, time of light, time to reach maximum height, time to reach maximum what? Height. Please follow. Time to reach what? Maximum height. We have maximum height itself, range, time of light, time to reach maximum height, angle of projection. So now that's that about that. Also here they usually ask if an object is projected on the height of a building, calculate the total height and the likes like that. These are the questions you are likely to meet in the exam for projectile. They can also ask you to define what? Projectile. Define projectile. They can ask you to define projectile and trajectory. Go and know that one. Trajectory is the path followed by what? By an object undergoing a projectile. For example, if you throw a stone or you shoot a catapult, the pathway that stone follow is what we call trajectory. So it's a what? It's a usually question that usually asks. And what does projectile is? Projectile is a body that undergoes a parabolic path, that undergoes a parabolic motions under the influence of what? Gravity. So that's all about projectile. Now, I have to define projectile. List example or application. Example and application of what? Projectile. Application of what? Projectile. You can see it in gunshots. You can also see it in what? In gunshots. In javelin throw. You know, these are sports activities. In javelin throw, discus, and so on and so forth. These are the application of what? Of projectile. They might ask you. These are the questions that are likely to be asked in projectile. Then we move to what? We move to what? Electric current. That's an exceptional question. We have electric current. Here is usually much in what? In objective. Electric current, energy, electric current, energy, and power. These three topics are usually common in objective, but they can chip into the theory aspect of the theory aspect as well. They are usually an objective question, but it's a very wide topic itself. But I will make sure I simplify all this topic before we go today. We have number 4. We also have a topic what we know as what? Wave. This topic is very interesting. Wave and its properties. Wave and its properties. Now usually this one is basically on what? They usually ask wave and the properties. You know, we are talking about wave. We talk about what? The types of wave. The classification of types of waves, such as the major classification, such as the what? The mechanical and what? And the electromagnetic what? Wave. The electromagnetic wave. So under the mechanical, we can also subdivide it into what? Under the mechanical, we can also subdivide it into the transverse and the longitudinal what? Longitudinal wave. And this wave has series of what? This transverse wave, they are what? The vibrations of the wave is perpendicular to the what? I'm still coming to that. I'm going to give us what? Details about. I'm just listing the what? The topics we are likely to meet in exam. So now from here now we have wave and properties. Then we can now talk about the properties of wave in full. Properties of what? The properties of wave. That is, when I'm talking about properties of wave, I'm talking about what? I'm talking about the refraction, the reflection, the refraction, reflection, diffraction, diffraction. Please follow the refraction, the reflection, the diffraction, the interference. The interference. Here we have what? We have under this interference we have constructive interference and destructive what? Interference, destructive interference. So these are the two types of interference that we have. Then also we have plane polarization, which is usually occur in light. Plane polarization. These are the properties of waves. You have to know all these terminologies. How we come across them, you have to know. Also, under the type of wave, we also have stationary waves. Stationary or standing wave. Stationary or standing wave. I just summarize wave for you now. This is just what you need in wave. This is the whole thing that you need in wave. All the electromagnetic waves, such as what? Microwaves, ultraviolet, infrared. Might not go into that one deeply, but if you can go into this, just try to know the definitions. And the last one in that wave is the wave equation. Wave equation. Wave equation. Now, this wave equation, you must know what? The wave, how to calculate wave equation and motion. So this one is, this is together. Please don't mix it together. I'm just trying to give you what you need to know as far as what physics 2023 Waec is what concerned. So now we have what? The wave equation and the wave motion. How to use the wave equation and how to calculate the wave motion, the common formula for wave and the what and its wave equation. So you need to know that as well. Other waves. I know wave can be a very wide topic, but I want to tell you, if you follow this method, you are on the right track of achieving your A. Now we have what? Number 5 question. Number five topic is when you move to what? To the topic called all this nuclear physics topic and the likes like that. But before that, let us consider what? The simple alternating current. The simple alternating what? Alternating current. So this simple alternating current, which is known as AC, here is also a big topic. We have a big topic here. So here we are going to be considering what? The types of what? We are going to be talking about the what? The type of circuits in what? AC. We are going to talk about what? The type of current in an what? In an AC circuit, and the type of voltage. You have the root mean square, current and voltage. So we talk about the root mean square, current and what? And voltage, which leads what? Which also bring about what? The peak current and peak voltage. So the root mean square, which is called RM, is what? Current and voltage. I want to talk about what? The type of series circuit, the type of the series circuit in what? Of what? This type of series circuit. Types of what? Of series what? Circuits in of type of series AC what? Circuit. How many type of series AC circuit? We have what? The inductor capacitor what? Circuit. We have e.g. the RL capacitor, the RC capacitor. We also have the RLC capacitor. So these are the major capacitors. The resistance, inductance, the resistance, capacitance, and the resistance, inductance, and what? Capacitor what? Series. So you have to know that the relationship between the potential what? Difference. The relationship between the potential difference and the relationship between the potential difference of the what? Of the potential difference of the resistance, the inductance, and the what? Capacitance. And also you must know how to calculate the impedance of a 3-watt circuit. The impedance Z. Impedance Z for RA, RC, and RLC circuit. You must know how to calculate the impedance for it. We also have something we call resonance. Now we're talking about resonance. We are talking about the R and the what? The L and C what? Circuit. The LC is common to L what? LC circuit. The resonance F0, the resonance frequency. The resonance leads to resonance frequency, and it's common to what? It's common to this circuit, L and C, LC circuit, of a simple alternating what? Current. Please note very that. What's the resonance? You might ask what's the resonance. It is a place where the capacitance, resonance frequency is what? Is where we have the inductance. The inductance what? The inductance is equivalent to the what? The capacitance reactance. That is L is equal to what? XL equal to what? XC. This is what we call reactance for inductance and reactance for capacitance. Don't worry, if time permits, I'll be able to brush through these topics so that you can be able to have the mindset of what? Of getting A and achieving your A in what? In this coming exam on Tuesday. So there is no cause for alarm. By grace we are going to conquer. Number 6. Now number 6, we also have what? We have what? The energy quantization. Energy what? Quantization and photoelectric what effect? Energy quantization and photoelectric what? Photoelectric effect. This is also important. This involves Planck's law, de Broglie law, and so on and so forth. Involve Planck's law. Photoelectric effect has to do with what? Planck's law, Einstein's law. We have what? We have what? De Broglie, de Broglie what? Sorry, the de Broglie what? Law. The de Broglie law. So we also have what? What other law do we have here? These are the major 3 laws. If you know how to use the word their law very well, HC equal to AC over lambda. This one say MC squared. This one say that what? The Broglie say AC all over lambda or lambda over C. It's not that it's postulated that. No, this one is postulated H equal to over P. That is the momentum, the Planck constant over the momentum. I'm going to go into this topic in details. So stay tuned. So we have what? 7. Number 7 here. Number 7 has to do with what? It has to do with the radioactivity. Radioactivity and nuclear what? Nuclear binding what? Energy. Nuclear binding what? Nuclear binding energy. Or you can call it what? Binding energy. You don't want to call it nuclear binding energy. We have what? Binding what? Energy. And this under radioactivity covers what? It covers the radiation particles and their properties. The radioactive particles and their properties, such as what? The alpha, beta, gamma, and what? And the alpha, gamma, and the beta ray. And also they can also include X-ray, but X-ray is not a what? Radioactive particle, but they usually compare X-ray with gamma ray. So now these are the things I need to know. First of all, the radiation particles. Under this, you have to know the radiation, the radioactive what? The radioactive what? Particles. And thereafter you move to what? Till what we call what? The decay constant. The decay constant and half-life. Decay constant and half-life. From there you move to what? To type of what? Energy, nuclear energy. We have nuclear fission and nuclear what? Fission. So the process by which you have what? Different type of nuclear what? Reaction. So we have nuclear fission and nuclear fusion. And the reaction that leads to the process, you must also know it. You must also know how to what? To balance the equation in nuclear what? Reaction, whereby they say this one emits what? Alpha particle, supply the missing numbers, whether the number of protons, about the number of what? Number of mass number, and so on and so forth. And these are the major topic, not but the major topic that are what? That are going to be in your exam. It's kind of what? Dominates your exam. Other topics you can see is electromagnetic field, gravitational what? I told you the other time, the gravitational field and what? And electrostatic what? Gravitational field and electrostatic what? Electrostatic field. You can also what? You can also meet a field of what? Capacitors and capacitance in your what? In your exam, but it is not that usually common, but you can meet it in objective very well. You can also meet it in first part of the what? Of the question, whereby you say you should calculate the energy in what? The capacitance or the potential difference, or so on and so forth. But these are the major topic. I'm not saying that you should, but when you know this one and you can really what? You can really boast of them, and you can really say to yourself that you know them, may you know that your A is guaranteed. Your A is guaranteed by the grace of God. So now I'll quickly rush into the what? Into this topic one by one. I have 8 topics here. I believe you are helping me to what? Note them as well. The first one is, let's write it there so that I can what? I can remember, because if I clean this up now, I might not be able to what? Recollect. So we have equation of motion. The equation of motion, we have the projectile. The projectile, we have the what? We have the electric current. We have the what? Number 4. We have the wave and the properties. Number 5. We have what? We have the simple alternating current AC circuit. Number 6. We have the what? The energy quantization. We have number 7. We have energy quantization that involve what? Photoelectric. Quantization and photoelectric. So number 7, we have radioactivity R. Number 8, we have the gravitational and what? Electrostatic what? Now, also there are some typical questions that can also come out here under dimensional what? We have what? Under A aspect, which is what? Number 9, which is dimensional analysis. Dimensional and dimensional analysis. It can also come out in section 8. So I'm going to start now, right now, by cleaning the what? The board. So now we have, I want to be taking it systematically and how we can be able to meet this topic in your exam. So the first one that you are likely to meet is the dimensional what? Analysis. That's topic 1. I'm taking it from here. Dimensional what? Analysis. Dimensional analysis. Now here I will just give you the hint that you need, because if I ask you to go into this topic in detail, you might not be able to what? Might not be able to cover all this stuff that I just highlighted. Now what do we need in dimensional analysis? The first thing is to know that we have 3 words. Major fundamental quantity, 3 major fundamental quantity, which is mass is L, the dimension of mass is L, the dimension of what? Length is L, and the dimension of what? T, of time is capital letter T. You must first know this first. Another thing that you need to know for dimensional analysis is that you must be able to recall for the formula of each physical quantity, like what is the formula for force? You must be able to write it. What's the formula for force? Mass is times what? Acceleration. So from the formula, you can easily write the dimension. Like the dimension of force now will now be mass times the dimension of the what? The mass of dimension of what? Force will now be what? Mass, which is capital letter A. Then the acceleration is what? Velocity over time. Velocity over what? Time. Acceleration is the same as what? Velocity over what? Time. And velocity itself is what? Is distance or displacement over time. So the displacement over time. So you are going to be able to say L over T. So when you bring them together, it's L per T squared. L per T squared, please. You can also get that from the what? From their unit. Acceleration is what? Meter per second. Acceleration is meter per second. This is length. This meter here is unit of length. So the dimension for length is what? For length is capital letter N. Dimension for what? Of S is what? T, which is what? Per second square, per T square. So this is F per T square, which is F. Dimension of this one is ML per T square. So this is how you get it. You can know fully well that the fundamental dimension that we use here is LLT. Then others are, these are the fundamental, but others are I. They can introduce I to you, which is the dimension of current. But these are the major ones that they will actually test you on. So now, from here now, how will you know the what? The formula of the physical quantity, you can easily find the dimension. And they can give you a dimensional question in word. In such a way, they will use that. They might say the velocity of a what? Of a wave traveling in a particular medium is directly proportional to the what? To the force and what? And the length. So they are going to give it in form of what? In form of variation, what you're just going to do is that you are going to interpret the variation. You are going to say V is directly proportional to length all over what? M. All over what? Length gradient, or all over M. Maybe like that. And it might ask you to find what? The K. V is equal to K L over what? M. And you put X, you find the what? Dimensional related to this. You put X here, then you relate it to, they want you to calculate the formula of this using dimensional analysis. You can say V is directly and inverse proportional to M. I'm just creating a question here. They might give you a wording questions. V is directly proportional to M and inverse proportional to what? M. And because you have removed this word, this proportionality sign, you put what? K there. And when you put K there, they might ask you to calculate what? To calculate the what? The relationship. What will be the relationship between V and all these parameters? Then what you are going to do after you have interpreted, you put X here. You also what? You also put, they might divide the constant for you, or you take the constant as 1. So it depends on how they divide. They might divide it, or they might say dimensionless or constant. So this, I'm just trying to summarize this question that you are likely to meet under dimensional analysis. What you are going to do is to find the dimension of velocity, which is what? Meter per seconds. The unit of velocity meter per seconds, that is distance over time. L what? LT. This one LT. So you put it in bracket equal to, I told you it depends on how they divide this one. If they say it's a dimensionless constant, so it means that you are not going to use it in the exam. So this one is what? Is length, over what? Length, and then what? We just say L, then L is the unit, then we have what? The mass, all over the mass, capital letter M, the unit of this one is capital letter M. So now how do you do that? In bracket what? X. Then you relate the things together, you relate the power together. This one is L raised to power 1 dot 2 or T raised to power 1. This one is L raised to power X dot M raised to power dot M raised to power minus X. When we relate this one together now, what do we get? X is equal to 1. Okay, S O. Now, listen now. Multiply this one by 1 out. This is L raised to power 1, L T raised to power 1, and this one is Lx. This one has come up to become what? M raised to power minus X, because I've already multiplied out. This is Lx, this is M raised to power minus X. Now, there is no M here, you introduce M. There is no M here, you introduce M here. That's how you do it. You introduce M raised to power 0, M raised to power minus 1, okay, 1, T raised to power 1. There is no what? T here, you can observe. You introduce it as what? T raised to power 0. So, M raised to power X, M raised to power what? Minus what? Minus X, then T raised to power what? 0. It's because I'm bringing the question off hand, so don't let it confuse you. T raised to power what? T raised to power X equals to 0. But don't allow that one to confuse you. If you are to add what? X now will now be equal to minus what? For this N now, for N, N is equal to 1. For M we have what? 0 equal to minus X. 0 equal to minus X. Then, in other words, you are going to have what? S is equal to what? 0, right? S is equal to 0. And that's how you get it, you introduce it. Don't forget that this is just a question coined from my head. But at least you can use dimensional analysis to interpret the dimension of a given physical quantity, because it might say write the dimension of the following physical quantity in the theory aspect. So what you need to know is that the formula must also come to your head. Then after that, after you have written the formula, note the dimension of the basic fundamental quantity, which are the mass, capital letter M, the length, capital letter M, and the time, capital letter T. So, and then they might also ask you to analyze a particular relationship using dimensional analysis. So the first thing is to first interpret the questions. It might not necessarily be like this. Just interpret the question in terms of relation as given to you in the question. P is directly proportional to so, or inversely proportional to what? You know, directly proportional is, you don't used to use 1 over. Why Why inversely you have to use 1 over, as I have done here. So then you put x or y or z on them so as to relate the left hand side with the what? Right hand side. So, and be able to what? Get it. Don't worry that this one is supposed not to be there because this power here must be tally with this. So that's that about what? About that. So that's that about dimension analysis. You can quickly get past questions, keep solving it, keep getting to keep improving yourself on the topics, and then I promise you that when it come out, you're able to tackle it very well. So that's that about dimension analysis. I'm going to the what? To the aspect of the what? Of the equation now. The equation. Now I'm talking about equation of motion. I told you it's a very wide topic. It's a very wide topic, but it can be very, very what? Interesting. So now the equation of motion has to do with what? Two aspects, the kinematic aspect of it and what? And the equation under what? Under motion. Now the equation under motion, the first thing you need to know is know the parameter used in the equation. The what? The distance, the displacement, the velocity, the acceleration, the deceleration, and what others, the constant speed, the constant what? The uniform velocity. Now what do I mean by that? The distance d, the what? The distance d, you must know the word distance. Distance d, the what? The displacement x. The what? The distance d, and sometimes they might represent what? Distance as what? X. The displacement what? Capital letter x, this x type. You must know the velocity, because knowing this one will help you to what? To know the topic very well. The acceleration, the deceleration, which is minus what? The deceleration, which is minus what? Acceleration or retardation. As deceleration and retardation, these are the what? Major what? Parameters that you must what? Know. R or minus A. Now, if you know this one very well, then you move to what? How do you know this one? This one, distance is just the magnitude between what? 2 points. The magnitude between 2 points. It's only telling you about the distance, the magnitude, the size between point A or point B without direction. So distance has to relate with speed. Speed over what? Over time. Speed. This has to relate to a distance over what? Speed relates to a distance rather. Speed related to a distance, which is what? Distance over what? Time. While displacement has to do with what? The magnitude of a what? Of a 2 point. The magnitude of 2 points in a specific direction. So displacement, velocity is the same as what? Displacement over time. Velocity is related to displacement. This is scalar. This is what? Vector quantity. That is what you can see. This one objective, which is following is what? Scalar, which is one is what? Vector. Speed is what? Scalar, because it has no direction, while displacement is what? Vector, because it has what? Direction. So invariably, because velocity is depending on displacement, it's going to also be what? Vector. Because speed is depending on distance, it's also going to be what? Scalar. So these are scalar, these are what? Vector. So that's velocity. I'll divide velocity, a change in displacement over what? Time. Then the acceleration is what? V over what? The initial minus what? The final minus the final velocity minus initial velocity will give you what? Acceleration. The final velocity minus initial over time will give what? Acceleration. Just deceleration is just the negative of what? Of acceleration. Deceleration is the negative of what? Acceleration. So how do you know these parameters? What are the things that you need to know in equation of motion, and how do you apply it? Number one, know the form equation of motion. The form equation of motion is very, very important, and how you can apply it. Form equations of motion, very, very important. They might even ask you to what? Derive it, but that deriving is very, 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 very what? The probability of coming out is very, very what? Low. So what are the four equations of motion that you must know? V equal to ut plus what? At. S is plus u over v in the bracket what? T. This is not likely common, but E is taken, I take it as one of the what? Equation of motion. You have S equal to ut plus half at squared. Then v squared V square is equal to U square plus 2 what? AX. These are the 4 equations of motion. Now, how do you use this one? How do you use this formula? The first thing you need to note is that when they say a body is at rest, it's not moving, meaning that the initial velocity is equal to what? The initial velocity is always equal to 0. Because there are sometimes people know this equation, but they didn't know how to apply it. When you say a body is at rest, it means that the initial velocity is at what? 0. Now, when they tell you that what? The body is already moving with what? With a velocity, meaning that its initial velocity is not 0 at that time. So, note that when the body moving with what? A velocity of what? Or 20 meters per second, they are referring to initial velocity because it already started moving. But if it's not moving, U is equal to what? 0. And now, all the other things that is very, very relevant here is when they are telling you that your initial velocity was able to decode your initial velocity and what? The final velocity. The final velocity sometimes, you might say the body has come to rest. It's coming to rest. That the body moving in 20 what? They might say a body moving with 20 meters per second. There, when they say a body moving with 20 meters per second, the initial is not 0. It's the initial will be 20 meters per second. It's coming to rest. So meaning that what? The eventual what? Final velocity is going to be what? V equal to what? 0. Because it's going to come to rest and become hot at a particular spot, which is 0. So we were able to decode which one is U, which one is V. Because if you cannot decode your parameter, you are going to apply this formula wrongly. So the first thing is to interpret the questions, visualize it, and then be able to apply this formula. The first thing is that when they say the body is at rest, know that initially is equal to 0. When the body is coming to rest, the final will be what? Equal to 0. So that's that. Another thing you need to know is that you need to understand the principle of behind what? This word. Which one will I apply at the time? It depends on the parameter given to you. It depends on the parameter given. If you are in a question where you are asked to calculate the velocity and you are given U and A and then time, then use this formula. If you are a type whereby you are not given what? Acceleration and you are asked to calculate distance and you are given velocity and initial velocity from your question, you have to use this one. But if you have acceleration, you can use this distance formula. So if we don't have what? If we don't have let me say we don't have the time, then you can use what? V square, U square plus 2AX. So that's how this formula works. It's very, very important what you know them. So another method of calculating the equation of motion is when you use graphical method. In fact, Waec can bring graphical method as a theory question. Yes, they have been doing it before and they can do it this time around. So another use what? Graphical method is solving what? The equation of motion. Graphical method of what? Graphical method of solving what? Problems on motions. On motion. How do you do that? Problem on motion. Now, the first thing is to understand which part of a graph represents this physical quantity we are talking about, this initial velocity, final velocity, time, and so on. Which part of graph can I use to represent them? Now, for instance, now we have what? When you have something like this, we have velocity time graph. This velocity time graph, we have velocity then against what? Time. When they say a body accelerates with 20 meters per second or with 10 meters per second, it means that we're going to form a sloping what? A sloping line, a line with a gradient. So this aspect represents what? Acceleration. Acceleration. Please know that this velocity is increasing with time. So if you are to interpret the questions, and I said, use graphical method to solve the following problem, and they said the body accelerates with 2 meters per second, meaning you are going to jump from the origin 0. If they say the body starts from rest and accelerates, you start from the origin. But if they say a body which has already moved with an initial velocity of what? Or which is already moving with an initial velocity of 2 meters per second, it has already started moving with what? Initial velocity of 2 meters per second. Meaning that what? At this velocity here, it will start by 2. Now, it's what? It's moving with initial velocity of 2 meters per second and then accelerates from there. Now this is not from rest again. It's already moving before it starts what? Accelerating. So you give it what? 2 meters per second. 2 meters per second, then you what? It undergo acceleration. So it depends on what? How the question comes. If you say your body accelerates from rest, it's starting from 0,0. But if you say a body moving with initial velocity of 2 meters per second, of 2 meters per second, then accelerate with what? With A, maybe 4 meters per second square. Please know that it's not that difficult. It's not difficult. Velocity with time graph. Velocity with time graph. So acceleration is used to represent a slope. What? This is gradient is used to represent what? Acceleration. And now depending whether it starts from origin or the body is already what? It's already in motion. Then it now took off on the what? In a particular what? Acceleration. Now from there now we what? We also said that whenever a body now undergo a constant or uniform velocity. When I mean constant or uniform velocity, it means that it maintains its velocity for a particular period of time. Its velocity remains unchanged. And whenever we have velocity unchanged, the acceleration is equal to 0. Whenever you have constant velocity, acceleration is equal to 0. Now what do I mean by that? Now if you want to represent it on a graph, it means when you say the body is now maintain a certain velocity of what? Of 3 meters per second, maybe 3 meters per second here. Now it now begins to it's going to go on a straight line. This graph is going to go on a straight line what graph. And here A is equal to what? 0. Here A is positive. It can be also number plus 1, plus 2, plus 3. But here, when the body is moving at what? Uniform velocity. Uniform velocity. He said A is equal to what? 0. Then you may say the body now decelerate back. Decelerate. So meaning that A here is minus. Like decelerate means that what? A here is minus. Decelerate means it come back to rest. It's coming back to rest. Is what? Reducing acceleration. Now, so that's that about that. Now, that's how you calculate, you interpret question using graphical method under motion. And then how do you now solve the problem? You may ask to calculate distance, total distance cover. Now, you can use this one from area of the total area of the distance cover is usually determined by the area of the shape formed by the motion. The area of the shape formed by the motion is what you are going to use to calculate total distance. And this one can be done by considering the whole shape, or consider the individual component of the shape. Listen, this area can be calculated by what? By considering the whole shape, if it's total, or considering the individual component of the of the shape. For instance, now this one is a trapezium. You can easily use half into bracket A plus B H. That's the area of what? Trapezium, right? Area of trapezium, which is equivalent to the total distance covered during this journey. Please follow me. Which is equivalent to total distance covered during this journey, because the area here is what? The area here form what? Trapezium. So that's that about what? The area of what? Trapezium using the whole shape. Now, if you are now asked to calculate what? The distance in the first phase. This is first phase here. This is another phase. This is another phase. So now they can ask to calculate distance in phase 1, phase 2, phase 3. They might not say phase 1, phase 2, phase 3. They can say in the first 5 seconds. Maybe this one can be 10 seconds. This one can be what? 20 30 in add up. It's always add up. 5 plus 5, 10 plus 5, another 15. In case of, depends on how they give to you. Please don't miss it up. I'm still coming to what? So now, yeah. So this is phase 1, phase 2, phase 3. They might ask you to calculate the distance covered in phase 1. What I'm going to use, just use the area of triangle. This is triangle, area of triangle, area of rectangle, then area of what? Another triangle. How distance side? This one is length times breadth. and this one is what. So that is how to calculate distance in physics. But if you say total distance, just use area of trapezium, then or you calculate the area of this, area of this, area of this, and then you add them together. So that is how to calculate interpret question. Now, there's some question that will come like a house, like this one, that a body moving in what initial velocity accelerate to distance, come here, and also what it decelerates for some y for 2 meters per second, and then it what it's now what it now also what it go like this, come back again. Don't be confused with this type of diagram. It also needs interpretation. So a body with moving initial velocity of 2 meters per second accelerates for 4 meters per second what square, then decelerates for 2 meters per second square, then maintain a velocity of what 5 something, and then decelerate. It's still the same thing. What you just need to do is what? Try to trace the what? Look at this. This one has already formed trapezium, because this is what? This trapezium, this is another trapezium. This is another what? This is rectangle, and this is right angle triangle. So we have trapezium. This is what? Another trapezium. This is another trapezium, because this is it. If you trace this one, it means trapezium. This one is rectangle, and this one is what? This one is what? Triangle. So you want to calculate the total area distance now. Total distance, which is the shape of the what? Of all the area of this what? Of this diagram. So area of triangle plus area of rectangle plus area of trapezium plus area of trapezium, it gives you what? Yours is to just know how to know where is your A, where is your B, where is your what? Others. If you have not understand this question of what? Motion, equation of motion for this exam, there is what? You can try and check my videos and look for equation of motion under JAM. I did it under JAM, that question for JAM classes. So you can go and watch a whole video on what? On equation of motion. Yeah, I promise you are going to get everything. If you don't get it now, even with the way I explain now, go and watch the video, and it's not going to waste your time. You are going to get the whole lot of tips from it. But that's that about equation of motion, how to solve it graphically, and how to use the formula method depending on your choice or depending on the question given to you in the exam. So that's what you can meet under equation of motion. And it can also tell you to mention type of motion: translational motion, rotational motion, simple harmonic motion, oscillatory motion, and so on and so forth. There are different types of motion. You must know the example of each motion. Simple harmonic motion, it has to do with what? The what? Simple pendulum what? But the oscillatory what? They have rotational motion, that of the hand of clock moving like that and like that. We also have what? The translational motion, the beating of the drum, and know them and know the examples. It might not, never can tell. You can also ask that kind of question. We also the Brownian motion in a zigzag manner, the Brownian motion. So that's that about the motion. I'm done with this, and what? This. Then let's talk about what? Equation under gravity. Equation under gravity is a little bit different. Equation under what? Gravity. But I'm going to use this what? This formula of equation to talk about what? Equation under gravity. Please listen. Okay? Now, equation under gravity has to do with what? This four equation. Equation under gravity has to do with what? Four equation of motion. So what are you to consider under equation under gravity? Number one, you must know when a ball is thrown up. Now, if you throw a ball up, now, it's going from the ground to up. Is acting against acceleration due to what? Gravity. When you throw something up, it's going against what? The gravity. So A here will automatically tend to what? G. Note that. A will automatically tend to what? G. So if I'm going to what? Use this word expression, I'm going to put minus G instead of what? Instead of what? Instead of A. So now also note that as it's going now, the velocity here, the starting velocity will be equal to 0. The final velocity is going to be what? 0. Then the initial velocity will be what? We can't. Because it's going up. But when it's coming down, the initial velocity is going to come to 0 at this point. Why the velocity? Okay, the velocity is going to come to what? The initial velocity is going to count or it depends on the question anyway. I can just give you this one in fact in details, because the initial velocity here is going to be what? The initial velocity here is going to what? Be 0, and it's going, if you start from where the initial velocity is going to be 0. But as it proceeds, the initial velocity will continue to go. So, but the most important is that A is minus G, and then when the ball is coming down from a top, or is dropping, or a foot drop down, the A is always what? Positive what? G. So if you just incorporate it inside this formula in this form, this is going to be V equal to U minus what? GT. Now it now depends whether velocity is going to be 0 or what? Or it's not going to go to 0. So minus GT, this one will become what? But in this place, it's still going to be what? V equal to U plus what? GT. If you understand this very well, you'll be able to solve motion under gravity. In fact, you'll be able to use it for what? For projectile, because there are some projectiles that involve throwing from down. You might say you are on the top and someone throw up and down. So equation of gravity has to do with what? Changing how to manipulate your A, whether it's coming down or going up, minus G or plus G, when V is equal to 0 or when U is equal to 0. If you can get that. And sometimes when it comes to equation of what? Under gravity. I'm talking about equation of under what? Gravity now. Under gravity. Equation under gravity. They can also change the distance to what? Height. Yeah, note that. Instead of them giving you the distance, they will say that from an height. So you automatically change the what? The distance into height. Automatically change the distance into height. Please note that. So meaning that what? This can change what? Height. And it means that, especially in this formula is very, very important. Where the initial velocity s equal to ut plus half at squared. You want to use it for a what? Equation of motion. It usually change form. Where the what? S is going to be h, that is distance from where the ball fall down, and u is always equal to 0 because it's coming down. And when it's coming down, u is always equal to 0. But when it's going up, u is always what? Constant. It's always having number. So u is equal to 0. Then when it's coming down, it's always equal to 0. Please note that the velocity and initial velocity, you have to master it very well. We have to master it very well. When a body is going with an initial velocity, it was thrown with an initial velocity and it's coming to rest at V at the final velocity is coming to rest. It means that the U can change to 0 at rest. Velocity can change to 0 at rest. So note that very, it depends on the question. That's why I don't want to give you a stipulated word. I don't want to give you a theory that might not be applicable for all. But this one and this one are very applicable. Now it depends on how the question now twisted in order to know when U is equal to 0 and when V is equal to 0, because it's going to help you determine the equation to use. So S equals to what? U equals 0 in this place when the body is thrown from what? From the top of what? Of a cliff. So now from here now you can now say that U equals to 0, S equals to H, and because it's coming down, we are talking about this, because it's coming down, then we say the acceleration is equal to plus what? G. So it's going to be plus G. So we have what? We have X equal to UT 0 times what? We have what? Now substituting this now, GA is equal to what? G. I say S equal to H equal to 0, A equal to G because it's coming down. So substituting that now, we have H equal to 0 times what? T plus half GT. So we have H equal to half GT. So now if you calculate, this formula is not used to calculate time. So T is equal to 2H over what? G. This formula is very, very essential. 2H over G to calculate a time taken for an object to draw from a particular height is very important. T is equal to what? 2H over what? G. If you cannot record all this process, remember this formula. Remember this formula. So that's that about what? That. Now let's go to the next topic Let's go to the next topic, which is what? Projectile. So let me clean up this projectile. So